Okay, so the next section is actually going to solve exponential and logarithmic equations. So we've already done some solving of exponential equations. It's when we could get the bases the same. So now we're going to start talking about what if we can't get the bases the same, that we can use the rules of logarithms to solve. So looking at the first example, we have 7 to the x power equals 83. We can't write 83 as 7 to some power, so we can't use the rules of that we did with exponential equations with setting the bases the same. But what we can do is take the log of both sides. So if I have log of 7x equals log of 83. So just think of it like basic equations that you've learned before. Right? Whatever we do to one side, if we do it to the other side, they're still equivalent. Once we've done that, we can use our rules. In this case, we're using the power rule, that the exponent can come out in front. So in this particular case, power rule, oops, that's just supposed to be W. So the power rule says x comes out in front. So this is why logs are so cool, because when we couldn't solve this, we couldn't figure out what the exponent would be. That power rule lets us put that exponent out in front, and now it's basic algebra. We want to solve for x. It's being multiplied by the log of x, so we divide by log of x to get x alone, or log of 7, sorry, to get x alone. So our last step is to solve. And so then you're going to need your calculator. Log 83, end the parenthesis. Divided by log of 7. So we take the log of 83 divided by the log of 7, we get 2.27, and just want to clarify that we're not using the rule that division is subtraction at this point. We're straight out just putting it in our calculators and dividing it out. So let's look at the next one. So the first one was an exponential equation that we couldn't solve using our exponential rules. Our second one is a logarithmic equation. So our first step here is to rewrite it in exponential form. Now notice, there's just an x over here. If we had log of something over here, then it kind of changes it. So as soon as we have log of something to a particular number or variable, then you're just using your rules to rewrite in exponential form. So first step, rewrite. In exponential form. So remember that's taking our base to that power equals that number. So 6 to the x equals 239. Now it's just like the first problem that we did, right? So it seems weird. It was in logarithmic form. We rewrote it in exponential form. Now we're going to take the log of both sides. And the reason why we had it in log and then not and then again is because we needed the log of both sides in order to get it in a form that we can solve algebraically. So now you're going to take log of both sides. Use your rule again to simplify and use that power rule to bring the x out in front. And then divide by log of 6. Put it in the calculator and get your answer. And I got 3.06 if you round. So next one, now the variable is in the base, okay? So we have to figure out what that base is. And again, we don't know what base raised to the 5.2 power is going to give us 112. So we're going to use the rules of logarithms again. So we're going to take log of both sides. Use your power rule. For the exponent. Here, when we start to do the algebra to solve, it's the log of x. So remember, those are attached. That's one quantity. You can't separate them, right? So we can divide by the 5.2. So now the question, we can do the log 112 divided by 5.2, but then how do we find x? Okay, so we use the power rule. We isolated the log of x, right? So now we want to know what number, what value for x that when we take the log equals whatever this is. So what you're going to do in the calculator okay, so we want to solve this. So I'm going to put the log 112 divided by 5.2 in the calculator. So log 112 divided by 5.2. Then you can hit enter. Make sure I have the right numbers, okay? Now we want to know what value of x, right? The log of what? So what you're going to do is do second log. Notice that's also 10 to the x power. So you could just simply use 10 to that power. What helps is that the 10 to the x power and the log are the same button on your calculator. So it helps you remember if I'm doing log, if I need like inverse log, then I would hit second log. Think back to some trig stuff when you wanted to find the sine of an angle. Remember you hit second sine or second cosine or second tangent. Same idea. Now you could type in this number or hit second and then answer, and that plugs in the number for you. Your calculator's slightly different because you don't have an 84, this is an 84. So yours will show it next to it instead of in the exponent. But it should still say answer, and then you don't have to retype the whole thing and then hit enter. So 2.48. So our last step, solve for x using second log, which is also 10 to the x power button. Okay, next page. Maybe. There we go. Okay, this one we're also going to use the rules, but so far the only thing we've used is the power rule. Now we're going to use that addition is multiplication. So your first step in trying to figure this out is to use the rules to condense it to one logarithm. So we would just have log plus is multiplication, x minus 1 times 2x minus 3. Okay, so if you want the steps again written down, so use rules to condense equation. The next thing we're going to do is rewrite an exponential form. So what you have to remember here is there was no base given. So remember that our base is 10. Right? When there's no base, it's base 10. Now I can rewrite an exponential form. 10 to this power equals all of that. So 10 to the first power, which is 10, equals x minus 1, 2x minus 3. Now you're just back to basic algebra, solving an equation. So you're going to use your algebra. To solve. So this has to be multiplied, double distribute, or what we call FOIL, right? 2x squared minus 3x minus 2x plus 3. Set it equal to 0. So I have 2x squared. Combine negative 3 and negative 2 to negative 5x. I'm subtracting the 10. Right? If I'm setting it equal to 0, then I have to subtract the 10. So we would have negative 7. So now you want to factor, or what we would call reverse FOIL. So pause the video and see if you can do that on your own. So if you factor it, you get 2x minus 7 times x plus 1. 2x minus 7 equals 0. Add the 7, divide by 2, you get 7 halves. X plus 1 equals 0. Subtract the 1. So remember, go back to the first day. We can only take the log of positive numbers. We can't take the log of 0 or negative numbers. So it's not the negative number here as an answer that matters. It's when I plug it back in. So if I went back up to the original equation and I plug in negative 1, negative 1 minus 1 is negative 2. Log of negative 2 I can't do. Okay? And if you did it in your calculator, you'd get an error. So negative 1's not going to work. 7 halves, so 3 1/2. 3 1/2 minus 1 is positive. 2 times 3 1/2, 2 times 7 halves, right? So checking this one. 2 times 7 halves would just be 7. 7 minus 3 is positive. So 7 halves would make this positive and this positive, so it works. If 7 halves made this work, but it didn't, let's say here it made it negative, then it doesn't work. So if it doesn't work for one part, it doesn't work at all. It's not part of the solution. So we're not going to accept that answer and just keep this one. So just as a last step, don't forget to check. Right? Because we can't take logs of 0 or negative numbers. So the domain x is greater than 0. See everybody on Monday. Now we're looking at the exit ticket problems. And the first problem is 6, 3 to the x equals 532. So the first step on this is to divide by 6. Here you can just leave this as 532 divided by 6. You don't have to actually find the value. Then you can use the rules, x taking log of both sides, and x comes out in front. Then you're going to divide by log of 3. So you can do this in a couple of steps in the calculator. But you don't actually have to find that value yet. You can do it here. And then quickly, you guys can finish that, but also look at number 2. Remember that ln is just the natural logarithm. All the rules of logs are the same for ln. So you have a 3 out in front. So the 3 comes up as an exponent. Addition is multiplication, so you have x cubed times 2, so 2x cubed, or 24, sorry, it's 24. Notice in this one, compared to the one that we did in the notes, that we have ln on both sides. So if we have ln on both sides, we don't need to rewrite or anything like that. We can just say then that 24x cubed has to be equal to 3. And solve from there.